It's been on television for 30 years, 30, 30 years, non-stop. Okay. So, why am I talking about all this? If you remember 1996, 1997, when IBM came up with what was called Deep Blue, which was a system that was able to play the game of chess and actually beat the champion at the time, Garry Kasparov. So for a few years, 2005, 2006, IBM decided that it was time for the next grand challenge. And decided to get into the space of natural language understanding. What is natural language? It's just the way I'm speaking to you right now. Let me know if you need me to slow down or if you have any questions, okay?
Yeah.
All right, so at the time, the technology about understanding natural language, if you give yourself a scale this high, where this is the maximum, so this is a human being understanding language, the technology was about this high, okay? So very little from nothing, basically at the level of a child 7 or 8 years old. So not very sophisticated. IBM decided to get into this and to try to actually compete in the game of Jeopardy. And the challenge was to compete against the top 2 champions of the game ever. So IBM considered this the new era of computing that it calls cognitive computing. Now why? This is the definition that you find in a dictionary. What is cognitive? Of or pertaining to the mental process of perception, memory, judgment, learning, and reasoning. The last 2 words are the key words when it comes to Watson. Okay? Learning and reasoning. The reason that Watson can learn from the information that you're giving it, and can also learn from feedback when you ask Watson a question and he doesn't get necessarily the right answer, but you tell him this would be a better answer. For the game of Jeopardy, there were 2 main challenges. So, understanding natural language questions over a broad domain of knowledge, because in the game of Jeopardy, the questions can be about virtually anything. History, math, science, geography, politics, movies, architecture, religion, anything. It had to give precise answers because, unlike real life, in the game of Jeopardy, there's only one valid answer. In real life, it's another story, but for the game of Jeopardy, one answer. Accurate confidence. So the same way when you are in class and the teacher asks a question, you have to, mentally you are computing whether you are confident enough that you know the answer before you raise your hand. Watson had to do the same thing. It had to compute a confidence level in its answers, or possible answers. And again, consumable justification means that before you raise your hand, you're assessing, yes, I know this topic because I know this and I know that, therefore I believe that this would be the correct answer. Those are justification, consumable justifications. And finally, it had to do it in a very fast response time, because since you saw the game last night, you have to be able to buzz in within 2 or 3 seconds. You may have seen this on the internet. So those were the top 2 players ever. Ken played 74 times in a row and lost on the 75th. So that's amazing. and he won $2.7 million. Brad played fewer times, but won $3.2 million. Anyway, just to give you an idea of how complex it is to understand natural language, I'm going to pick a clue from the actual game of Jeopardy, and I'm going to analyze it with you. So the question says, if you are standing, well, every human being understands if you are standing. There's nothing complicated there. But try to explain that to a computer. A computer does not have any sense of its surroundings. The computer is not self-aware. So the concept of standing is a little difficult to explain to a computer. It's the direction you should look. That's okay, there is nothing complicated. Check out in English can have at least 4 different meanings. And there are probably more than 4, but I can think of 4. There is the checkout counter in the grocery store, in the supermarket. When you're staying at a hotel and the next morning you're leaving, you are checking out. There is the, you need to verify something. Oh, did I put this on the grocery list? I have to check out if I actually put it on the list. That's the 3rd meaning. And the 4th meaning is you're listening to a conference, and after a while the speaker is a little boring and you stop listening. Your mind wanders. You check out. That's another expression. So already 4 different meanings of the word check out. And finally, the wainscoting. Well, I'm almost sure you don't know what the wainscoting is. And don't feel bad, because until I took this job a little over a year ago, I didn't know what the wainscoting was. And I've been in the US for 33 years. Okay? Well, the wainscoting in this room is this, the baseboard. Okay? So now let's go back to the whole question. If you're standing, it's the direction you should look to check out the wainscoting. So where should you be looking to check out the wainscoting? The answer is down. Or in the game of Jeopardy, you have to give the answer in the form of a question. So what is down? So you see that for something that is seemingly very simple, once you start analyzing it, it's not that simple. So understanding natural language is a rather challenging endeavor. Let me skip a few things to show you what the system was actually made of. Oh, skipped it. Okay, this is what the system that played Jeopardy during the championship was made of. Nowadays, it's much simpler, but this was February 2011, so almost 3 years ago. 90 servers, so it's not a small system. Almost 3,000 cores, so that's a pretty significant system. And the number that I like to point out is this one. But let me ask you a question first. In your typical personal computer, how much memory do you have?
4 gigabyte.
Yes, about 4 gigabytes.
Yeah.
Multiply that by 4,000, and you get this number, 15 terabyte of memory. That's what the Watson system that played Jeopardy was made of. Now, why this astronomical number? 2 reasons. One, Watson was not connected to the internet during the competition because the other competitors were not.
Yeah.
Okay, didn't have access to the internet either. And 2, because it had to have all of its knowledge in the system, because it was not connected to the internet, it had to give answers very quickly, and relying on disk access alone would have been prohibitively slow. Way too slow. So all of its knowledge had to reside in memory. And that's the reason for this very large amount of memory. After the competition, IBM decided to get into 3 different industry spaces. The first one was healthcare, and the reason for selecting healthcare is that it affects society as a whole. The second one was financial services, and the third one was call centers. And what I'm going to show you now is the example of in healthcare, because IBM partnered with a well-known cancer center, Sloan Kettering Cancer Center in New York City. They worked with their researchers, their doctors, and the IBM researchers, the Watson researchers. They worked together for 2 years to build a Watson system that would be able to assist a cancer specialist, an oncologist, in diagnosing patients. And they look at the first few pages of the medical record because that's all the time they have. So if there is something important that is maybe 5 or 10 years old or 20 years old, it's in there, but they're not going to know. But now imagine that you have an electronic medical record, and imagine that Watson can actually go through your entire medical record and compare it to all of its knowledge about medicine, and in particular cancer, and specifically lung cancer. So we're going to ask Watson to actually analyze the electronic medical record. So Watson reads this and it compares it to medical journals, clinical trials, doctors' blogs, you name, textbook, medical textbooks, you name it. And once it has completed the analysis, it comes back with a summary of what it has found. And it highlights the key points of what it has found. So it has the pathology report, the CT chest, it has the primary care physician notes. But what is also very important is that Watson knows what it doesn't know. And what do I mean by that? View Watson as an assistant that you would be talking to. If you ask the assistant a question for some advice, the assistant may come back to you and say, but wait a minute, you never told me about this or that, and I can't answer your question without knowing that information. Well, Watson does exactly the same thing. If it needs some information it didn't find in the medical record, it's going to ask. And in this case it says, has the patient experienced any hemoptysis? Hemoptysis is coughing of the blood. You're coughing blood. And the reason it's important for Watson to know is that if you do have hemoptysis, if you have experienced hemoptysis, there are some drugs that you cannot prescribe. And then it is also asking, does the patient have normal hearing? Now, I'm sure you don't have any medical background, so you may wonder, what does normal hearing have to do with lung cancer? Well, Watson knows that it has a lot to do, because when lung cancer spreads, it spreads to the brain, and when it spreads to the brain, it affects your hearing. So Watson needs to know that, because if the cancer has spread, obviously the treatment is going to be different. So it's one way of knowing whether the cancer has spread. The same way you're talking to an assistant, the assistant gives you some advice, and you may say, okay, but why are you saying this? Explain to me, give me more details. You can do the same thing with Watson and ask for the evidence. Oops. Come on, there we go. And also, Watson, in advising the doctor, can recommend some tests be performed on the patient. And it's always the doctor that's going to make the final decision. So the doctor can select or unselect some of those tests. And again, we can ask for, okay, but why are you recommending this test? So you ask for the evidence. Watson will summarize what it has found and can give you even more details on some of the specifics. So if I ask for those details, Watson will open the article that it had found and highlight the passage of the article that is relevant to that question and is the reason why Watson decided to recommend this test. Now that the tests have been performed and the results have come back, we get the recommendation from Watson. Watson recommends 3 treatment plans, and if you recall what I said earlier, in real life there is never a single answer. It's only for the game of Jeopardy that you only have one valid answer. But in real life, any problem has more than one answer. And in medicine, it's no different. So you have 3 treatment plans. And again, Watson tells you its confidence level for each of those treatment plans. The same way when the professor asks a question in class and you assess your own confidence level as to whether you really know the answer. So in this case, Watson is more confident in this treatment than the others. But there's another twist to this. Patient preference match. What does that mean? Well, if you're any familiar with cancer treatment, you probably know that chemotherapy will make you lose your hair. So the patient in this case, being a young mother with young children, doesn't want to scare her children by losing her hair so suddenly. So she tells the doctor that she would prefer a less aggressive treatment in order not to scare her children. So Watson can take that piece of information into consideration and consider this treatment to be acceptable. This one would be the preferred treatment from the patient point of view, but it's not that good a treatment from another consideration. So, but this one is acceptable, so this would be probably the treatment that Watson would recommend and that the doctor would probably go along with. But again, this piece of work, the research, so to speak, was done by Watson in assisting the oncologist. In the medical space, the amount of information that is published doubles every 2 to 3 years. So no doctor is able to keep up with that amount of information. It's just impossible. So however, Watson can read and read and read all kinds of information and will remember everything it has ever read equally well. Whether it read it a year ago or 5 minutes ago, it doesn't make any difference. It remembers everything. So this is an actual a true assistant for the doctor who cannot be possibly aware of everything, all the new trials that can happen, all the new drugs that could come on the market, the interaction between all the drugs, and so on. Or again, like I said earlier, reading the entire medical record of the patient and maybe finding something very important deep into the record. The last step here is to request authorization from the insurance company. You may not be familiar with the medical system in the US, but for a treatment such as this, you have to ask for authorization from your insurance company. And the insurance company wants to review why you are proposing such a treatment. So the doctor needs to prepare a package to explain why he's recommending this particular treatment. But in this case, Watson has already done all the work, so it makes perfect sense to use Watson to send all that information to the insurance company electronically and automatically. And if the insurance company also has a Watson system, which doesn't have to be configured exactly the same way, doesn't have to have the same sources of information, because it may also have insurance policy documents that it needs to abide by. The Watson system on the insurance company side can analyze what the Watson system on the doctor's side has sent and decide, okay, this is acceptable, we'll pay for the treatment. And give the answer, give the approval back a lot faster, within minutes or hours instead of days or weeks. So what you've seen here is a real breakthrough. In the case of Sloan Kettering Cancer Center, it's been in production since almost a year ago. There has been other clinics in the United States that have also worked with IBM in building similar but different Watson systems to be able to help doctors diagnose patients.
So now they are using this system?
This system is in production at Sloan Kettering Cancer Center, yes, since March of 2013. Most complex diagnosis, and also because there is so much information that you need to be aware of before you can actually decide on a treatment, that it made perfect sense to apply Watson to this kind of situations because of the amount of information that needs to be looked at. Of applying Watson, not just in medicine. Obviously, medicine is a great world where we can apply Watson, but we have also solutions in financial services to assist people in investments, but also in call centers or in self-assist, where, for example, in call centers, it can assist the call taker in answering customers' questions, so that they don't need to refer them to level 2 or level 3 support. They can mine all the information by simply asking Watson. Watson comes back and gives the call taker information, which the call taker can relate to the customer. Once again, the call taker doesn't need to be aware of everything, but he or she has all the information at the fingertips. 2 weeks ago, IBM announced that we are creating a brand new business unit called the Watson Group, where IBM will be doing development, research, marketing, sales of Watson. And the reason this is very significant is that IBM very, very rarely creates a new business unit. Once every 10 years at best. Okay. So it's a very significant milestone and a proof of the commitment that Watson is here to stay. Announcement a couple of months ago, maybe 3 months ago, where they showed how they were able to not only find a new treatment for a patient, but also monitor the progress of the treatment and detect that a particular treatment was not right for a patient and stop the treatment before it got really bad. Basically, they saved the life of the patient using Watson. So it was a pretty significant milestone there as well. 90 servers and 15 terabyte of memory. Now it's down to 1 or 2 servers with a more reasonable amount of memory. I don't have the specifics, but probably, I don't know, 16, 32, maybe 64 gig of memory. But the reason that they were able to scale it down was that it no longer mattered, it was no longer important to have an answer in 3 seconds. It was okay to wait for maybe 30 seconds or a minute. Okay. It was not critical anymore to have an answer so quickly. So the requirements on the system itself were drastically reduced. And that's why they were able to not only scale it down to the, 1 or 2 servers, but also scale down the amount of memory. And Jeopardy in February 2011. It's been almost 3 years now, and to this day, we are not aware of any competitor out there that have come up with a similar system. So we have, to date, no competition in that space for understanding natural language to the level that Watson is doing. Okay. There are we have competitors in the area of analytics, but in terms of understanding natural language, to date, no.
They said they only using the English.
Good question. For now, only English, but they are working on other languages, and I believe the first other language is Japanese. And I sometimes get the question, but since Watson can read text so easily, why can't you feed Watson a dictionary? But as you probably know, you can't learn a language by simply reading a dictionary. A language is a lot more complex than that. So it doesn't work that way. But so yes, right now it's only English, but they're working on other languages. Had to be able to speak, so there was a voice, synthesizer. But normally, a Watson system is strictly interacting through, a screen, a terminal. There is no voice input or output because there is no real need for it. Yeah. That's not the core of the technology. The core of the technology is understanding the language in written form, in typed form, not doing voice recognition. Of course, Watson could do voice recognition, but that's not the purpose of Watson. Okay, Watson is there to understand what it reads, draw correlation between multiple documents that may be conflicting each other or may be agreeing with each other. And for example, you may have a clinical trial that says that drug A is the best that you can have, and then later on somebody else does a clinical trial and decides that drug A is no good for pregnant women, for example. But if a doctor only read the first clinical trial results, he's not going to be aware of the other one and may prescribe that drug to the pregnant woman. Or vice versa. The first drug says it's not good for pregnant women, and the second trial invalidates the first trial by saying this is not true because whatever. So Watson is able to realize that this second clinical trial invalidates the first one, and that's what everybody else is saying. But if there was only one source with that information, then Watson would not put as much weight into that information. So Watson not only understands what it reads, but can also draw correlations between the various sources of what it reads.
Can you
That's
measure?
all kinds of information from the internet, millions of pages, movie databases, articles, to be able to be knowledgeable in as many topics as possible. But this is not what a real Watson system is meant to be. A real Watson system is meant to be knowledgeable in a narrower space, but with a better knowledge of that space, and to be able to come up with answers that a human being cannot come up with in a reasonable amount of time. So I suspect that you would not be able to measure Watson's IQ, because if you train Watson for cancer and you ask Watson a question about something that is not related to cancer, Watson will not know. And you're going to say, oh, that system is pretty stupid. But that's not what it was meant for. So my guess answer is that you cannot measure Watson's IQ. It would not make sense. Well, for example, in the legal field, where the amount of written information is gigantic, everything is in text form, right? So Watson in the legal field would be probably a very good helper, a very good assistant, to be able to analyze, hundreds and hundreds and thousands of past cases, for example. Watson could be used to help diagnosing industrial products, planes, trucks, complex engines, the space shuttle. All those systems are so complex that when there is a problem, what do the engineers do? They go back to the manual and they read the manual. But those manuals, usually for a complex system such as a truck or an airplane or even just a jet engine, there are many components that are made by different manufacturers. And each manufacturer writes their own specifications and troubleshooting manuals. So if you have to read all that before you can come up with an answer, it can be a pretty difficult task unless you have the experience, but still. So there are considerations about applying Watson to the diagnosing of those complex systems in the industrial sector space. But definitely Watson can analyze the information that it is being fed and can draw inferences, relationships between the various pieces of information from the various sources of information. Whether Watson is actually thinking, I wouldn't go that far. It probably would be a little bit of a stretch. But it's definitely learning, because the more information you give it, the better it's going to be. You can also give feedback to Watson, and when the IBM researchers and the doctors at Sloan Kettering Cancer Center were training Watson, they were asking Watson some questions. Watson would come back with an answer, and they would give Watson feedback. Yes, this is true, or yes, this is not true, and why? And Watson would modify its algorithms so that the next time the same question or a similar question is being asked, it would come closer to the right answer. So Watson is a learning system. 100 in the original Watson.
You mean for the game show?
Yes.
I don't think it was that
Not
big.
even that
I
many?
think it grew over time.
Right.
I think it went up to maybe 25, something like that.
Oh, that's at the very beginning. Yeah, okay.
But in
Yeah.
the very beginning,
Right.
it was much smaller.
Yes, that's right. So only during the development of the first Watson system for the game of Jeopardy. There were about 25 people. And then the organization grew when it was made public. Then they created a Watson organization within IBM's software group. That grew to about 200 to 300 people. And now, with the creation of the new business unit called the Watson Group, that's going to grow even more. But I don't have specific numbers. That question, but what I can tell you is that I would not be surprised. First of all, you don't want Watson in your hand. You want to be able to access the power of Watson.
Yeah.
Okay? So Watson is more of a as a service. Watson as a service. So I would not be surprised if it's going to be accessible to the average consumer in less than 10 years, maybe 5. I can't predict that. But I wouldn't be surprised if it's going to be available as a service very soon, because it is already in the ecosystem that companies can use the published Watson API. API is Application Programming Interface, to build their own application based on Watson. So it's only a matter of time before a lot of companies decide that they need that kind of power for their business, but they don't need a Watson system. All they need is to be able to access a Watson system just when they need it. It's going to be a lot more efficient or financially, make sense. Would make more sense financially to only use it when you need it and pay only when you use it. So, is it going to be 3 years, 5 years, 10 years? I don't know, but it's going to happen. You cannot have a conversation with Siri. What do I mean by that? You can ask a question to Siri: what's the weather in New York? What's the weather going to be tomorrow? Or what about Washington, D.C.? Okay. But you cannot go beyond that and continue a conversation, because Siri's already forgotten what your original question was. Okay? With Watson being able to remember everything that it learns and everything that it acquires by simply interacting with Watson, you can have I'm going to say sustain, a continued conversation with Watson. Now, some people also draw the parallel between Watson and Google. They say, oh well, Watson is just a Google on steroid.
Yeah.
Okay. Well, that's not exactly right either, because the difference between Google, let's say you search something on Google. How would you put the question, what is the best treatment for this patient, on Google? You can't do it, because Google only understands keywords. Okay? Once you have found the right keywords, all Google is giving you is a list of documents that may contain the answer to what you're looking for. You still have to read those documents. With Watson, you're asking a question the same way you would be asking another human being in natural language. And Watson will come back with the answer, not a list of documents that you have to read. So that's the major difference between Watson and Google.
So here we're showing off some of the most significant inventions that came out of research. So for example, and they're kind of mixed up in terms of the date when they came out, but this is an early example of a scanning tunneling microscope, invented in 1981. And the researchers from the Zurich Research Lab received the Nobel Prize in Physics. So this allows us to make images of atoms. And one of the reasons that IBM continues to invest in basic science is that many times these kinds of developments, which was a basic physics invention, we're using derivatives of this technology today on future computer devices, you know, that are being built at an atomic scale. Fractal geometry was developed by Benoit Mandelbrot. And fractals are a way of...
Technology which is 10 to 15 years, two technologies that are 10 to 15 years apart. So, like John was saying, Deep Blue was a special purpose built computer just to be able to play the game of chess extremely fast. Okay? Watson is a completely different system which is able to learn, which is able to improve, and you just cannot compare.
Yeah, it was an impressive accomplishment.
Oh, absolutely.
But it was the approach that they took was a brute force approach. In the sense they were using the computing power to evaluate every possible chess move and then pick the best one. So they could use the system to play the game in a sense with all different chess moves and see which one was the next best move to make.
You want me to write it for you? Okay. David Ferrucci. 2 R's, 2 C's?
F-E-R-R-U-C-C-I.
Only 1 R?
I think it's 2 R's.
2 R's and 2 C's, right, okay. Okay. Ferrucci. Okay. He was an IBM researcher for I don't know how many years. Always worked in research as far as I know. And he started this with a handful, very few people at first. And then the team grew a little bit when they decided to actually do something with it, you know, decided to play the game of Jeopardy. When they decided to play the game of Jeopardy, that was only 2007, 2008, so they had about 3 years to be able to reach the level that would be sufficient to play the game of Jeopardy. And I think the director of research asked them, okay, so how quickly can you get an answer? That was about 2007. And they said, about an hour and a half. So they had a lot of work to do to be able to get an answer within 3 seconds.
But he's a computer scientist.
Yes.
How about now?